fraction. Rational expression just means that you have a fraction and you have x's everywhere, okay? Do not cancel before you think factor. Factor, factor, factor has to be part one. When you see a sign between two things or three things or four things, whatever, it's usually two or three, this is stuck together. This is one piece, one unit. And I can't take away part of that unit, part of that group. Never ever. You can take away a whole group, but not part of a group. Okay? So as I said, in bold, capital, with an exclamation point, you have to think factor first. So all your rules of factoring that we've been using apply. You won't see factor by grouping, but you'll see all the other stuff. Okay? Then what we're going to learn today is what can I reduce and what can I cancel and what can I not. So that's the new part for today. And then your answer is what's left after you reduce everything. So example 1, I'm going to go through my rules of factoring. Numerator, is there a common factor? Yes, I can take out a 3. When I divide 3, 3 divided into 3x is x, minus 3 divided into 9 is 3. My denominator is a monomial term, meaning there's no addition or subtraction signs. You can do nothing with a monomial, it stays a monomial term. So now, the x minus 3 is a group or quantity that's stuck together. Do not go into the group and do anything with it. The 6 is not stuck, I'm sorry, the 3 is not stuck to that though. And down here, the 6 and x are not stuck together. So there, I can reduce and cancel. So this 3 goes into itself 1 time, and it goes into a 6 2 times. So I can reduce the 3 and the 6, just like you're reducing a fraction. Leaving me in the numerator with x minus 3. Because this is a 1, I don't need it. And then in my denominator, I'm left with 2x. That's my final answer. So you're factoring and you're canceling. And you're factoring and you're canceling. So it's really all about factoring more than anything. Second example, in the numerator, do I have a common factor? I do not. So I count my terms. I have 3 terms. So that's my trial and error. X squared is x times x. Positive last term means look to the middle. So all my rules of factoring that I should know. And then last term is 2, 2 times 1. In my denominator, common factor, no. 2 terms, is it a difference of squares? Yes. So first term, x squared is x times x. 1 is 1 times 1. 1 gets a plus, 1 gets a minus. And then I look what I can factor, well, look what I can reduce, cancel out. Here's where I can cancel an entire group with an entire group. That's the only time you can cancel groups, is if they look alike. Or almost alike, which you'll see in a minute. So an x plus 1 can cancel with an x plus 1. It's a whole quantity canceling with a whole quantity. Leaving x plus 2 over x minus 1 as my final answer. And again, those x's don't cancel because they are part of a group. Next question. Is there a common factor? In my numerator, there is not. So I look at my terms. I have 2 terms. Is it a difference of squares? Yes. So 9, 3 times 3, x squared, x times x. 1's a plus, 1's a minus. In my denominator, is there a common factor? Yes. I can take out an x. and I'm left with x minus 3. Now, there is nothing in the numerator that looks exactly like anything in the denominator that I can reduce, but they kind of look alike. So this x minus 3 and this 3 minus x are called additive inverses. Additive inverses are simply two things that you can add together that give you 0. 5 and negative 5. Bless you, 4 times. Additive inverse is simply two things that you add together to get 0. 5 and negative 5, those are additive inverses. 8 and negative 8 are additive inverses. If I added 3 minus x with x minus 3, 3 and 3 would cancel, x and x would cancel, that would give me 0. Those are additive inverses. I can't cancel them as they look because they don't look alike. They're not exactly alike. But you need to recognize them because what you can do is this. You can take, when you have additive inverses, and you can make them look alike. So I'm going to replace that with x minus 3 as long as I take out a negative or add a negative to it. So I can make an additive inverse look like its companion. So I can make 3 minus x look like x minus 3 as long as I take out that negative. Now there's a mathematical process to it. I don't need to show you that because I don't expect you to do it. So now I can cancel my x minus 3's because they look exactly alike. And I am left with, in the numerator, a negative. I got that negative that I took out. That's there. It's part of my answer now. The quantity or group 3 plus x, and in my denominator, just that plain x. Yes?
So if you're changing it, you just have to add a negative to the whole problem?
Yep.
Will it always be negative? Or will
Yep. You were going to say if it was negative, would it become positive, weren't you? We're going to see that in goal 5 too. We'll see it. Hannah?
So like when we cancel out like the x minus 3 and the two numbers, we'll just leave the x on the outside there. And
So
then, okay. So like when we do the 3 minus x and we cancel all that out, the x on the bottom will just stay there because we can't cancel that out.
This one here?
Yeah.
Correct, because you're just canceling this group with this group. Okay?
Thank you.
What
Yes?
if it was x plus 3? Would it still be?
Those aren't going to be inverses. The inverses have to be subtraction. Okay, my next example. First numerator, okay, you'll notice that it's growing. This was one fraction. Now I have a multiplication. The only difference between this one and this one is usually more work, okay? Throwing that multiplication sign just means more places that could factor. 9 does not factor. It's a monomial term. X minus 2, no common factor. Not a difference of squares. It just stays x minus 2. Times, second numerator, x squared minus 4. Common factor? No. Difference of squares? Yes. So x times x, 2 times 2, plus and minus. And in my denominator, 3. Can't do anything to a monomial term. Monomial term, just no sign. And then I go to cancel. So I've got two groups that look alike, x minus 2 and x minus 2. And then I can also reduce this 9 and this 3. Monomial terms there. So that 3 goes into itself once, 3 goes into 9 3 times. And then in my numerator, I'm left with 3 and the quantity x plus 2. And in my denominator, just 1, which I don't have to write. If you wrote it, I wouldn't mark it wrong, but you don't have to have it there. After you reduce and cancel, what's left is your answer. Tiffany. Is your question? Gus?
If we put the 1, will it be marked wrong?
Nope. Lots of room there. Okay, next one here. A little bit bigger looking. First numerator. Common factor? No. Difference of squares? Yes. 2 terms. Difference of squares. So x times x, y times y, plus and minus. In my denominator, 3x plus 1. Common factor, no. Difference of squares, no. So just leave it. In my second numerator, common factor to all of these, no. So 3 terms is my trial and error. Now, for those of you who are really comfortable with your factoring, it's likely, there's a really, really good chance that there's going to be a 3x plus 1 up here. A really good chance. So keep that in mind when you're factoring this numerator, or this trinomial. So 3x times 1x. Last is positive, which means my signs are both the same. And then 1 times 2. And I'm going to use that little help. Doesn't mean I'm right, but let's check it and see. Outer times outer, 2 times 3 is 6. Inner times inner, 1 times 1 is 1. 6 and 1 gives me my 7, so I'm good. And then in my denominator, x minus y, common factor, no. Difference of squares, no. So it just stays the same. So you're looking at all 4 spots now to see if they can factor. So now I can cancel. Whole group, x minus y, with whole group, x minus y. Whole group, 3x plus 1, with whole group, 3x plus 1. Anything in the top with anything in the bottom. It can be in the same fraction or opposite fractions. It doesn't matter, just so it's top to bottom. Leaving, for my final answer, what's left up top. There's nothing left on the bottom. X plus y times x plus 2.